Hello everyone, welcome to the factoring test review. Let's jump on in. So number 1 says to factor m squared minus 64. So first off, I want to look for a GCF, and I notice I have a coefficient of 1 here and then 64. Those do not have a GCF, so I can jump straight into the methods I have for two-term polynomials. The only one we know is a difference of two squares, so that means we're going to have two factors. Remember, one has a plus sign and one has a minus sign. Square root of m squared is m, and the square root of 64 is 8. So in this case, the only method we used was difference of two squares. Looking at number 2, again, I look for a greatest common factor. I have a 1, 16, and 60. I do not have a greatest common factor there, so that means I'm just going to jump into my methods for three-term polynomials. In this case, my a value right here is 1, so that means I can simply make a t-chart, and I'm going to factor my c value of 60 to get a sum of 16. So we have 1 and 60, 2 and 30, 4, 15, 5 and 12, 6 and 10. So 6 plus 10 will equal 16, so this is going to be b plus 6 and b plus 10. And the method I used for this was a t-chart. We weren't able to use a GCF. Looking at 3, so first off, again, GCF, I have a 6, a negative 13, and another 6. Those do not have a greatest common factor, so that means I'm just going to jump straight into my three-term polynomial methods. So since my a value is not equal to 1, I am going to take 6 and I'm going to multiply it over. We're doing mfdrr. So m is to change this to x squared minus 13x plus 6. F is factor, so I'm over here. I'm going to write my t-chart. Oh, and that should be 36, plus 36. So we're going to factor 36 to look for a sum of negative 13. Since this is a negative 13, we know all of our factors are going to be negative, because two negative numbers multiply together to be positive, but add together to be negative. So this will be negative 1, negative 36, negative 2, and negative 18, negative 3, negative 12, negative 4, and negative 9. So the only one that works is negative 4 plus negative 9. So I'm going to have x minus 4 and x minus 9. Next step is D for divide. So I have to divide both of these by my original a value of 6. And then my first r is to reduce, so 4 over 6 is going to become 2 over 3. And 9 over 6 is going to become 3 over 2. My second r is to rewrite these. So we move bottoms up. So move the 3 up and move the 2 up. So this is going to be 3x minus 2 and 2x minus 3. And so the only method we used for 3 was mfdrr. Let's look at number 4. So again, we always look for a greatest common factor first. 3 and 27 are both divisible by 3. So I'm going to factor out a 3, and I'm left with y squared minus, and then 27 divided by 3 is 9. Now looking at what I have left, this is a binomial. We have two terms. So I'm going to see if I can take a difference of two squares. Y squared is a perfect square. 9 is a perfect square. So that means this is going to become 3 times, we have two factors. Remember, one has a plus sign, one has a minus sign. The square root of y squared is y. Square root of 9 is 3. So we're going to end up with 3 times y plus 3 times y minus 3. So this, we took a GCF, and then difference of 2 squares. Now let's look at 25, or not 5, let's look at number 5. It is 25s squared minus 20s plus 4. So 25, negative 20, and 4 do not have a greatest common factor. So that means I'm just going to jump straight into my trinomial methods. So my a value is not equal to 1, so I'm going to do MFDRR and multiply this over. So when I multiply 25 into 4, I get s squared minus 20s plus 25 times 4 is 100. Now we're going to factor, so make my t-chart over here. We're factoring 100 for a sum of negative 20. Since we're looking for a sum that is negative, but a product that is positive, all of my factors are going to be negative. So we have 1 and 100, both negative, negative 2 and negative 50, negative 4 and negative 25, negative 5 and negative 20, and then negative 10 and negative 10. We're going to choose the two 10s, so we have s minus 10 and s minus 10. We have to divide by that original a value of 25, that's d in MFDRR. So then our 10 over 25, that is going to reduce to 2 over 5. And I'm just going to put squared because these two factors are the exact same. So multiply them together, it's squared. Now I'm going to rewrite. So remember, bottoms up. We're going to move that 5 in front. So we're going to have 5s minus 2 squared. And so for this one, we only used MFDRR. Now looking at 6, I have a 4, a 12, and a 12, so I'm going to see if I can take a GCF. All three of these are divisible by 4, so I'm going to factor out a 4, and I'm left with x squared plus 3x plus 3. Now, looking at my trinomial methods, a here is 1 now because we factored out the 4. So we're going to factor 3 to look for a sum of 3. Now the only factors of 3 are 1 and 3, but those add together to be 4. So in this case, this polynomial is not, you can't factor it any further. What's left inside is prime. So the only method we were able to use is a GCF. And this right here would be your final answer. Looking down at number 7, so we have a 1, a 14, and a 49. Those do not have a greatest common factor. So since my a value is 1, I can go ahead and just set up a t-chart. I'm going to factor 49 to get a sum of 14. So my factors for 49 are 1 and 49, and 7 and 7. So 7 plus 7 is what gets me 14. So this is going to be x plus 7 times x plus 7, which is the same thing as x plus 7 squared because they're being multiplied by themselves. So for this one, we only used a t-chart. Looking at number 8, we have a 2, a negative 16, and a negative 18. All of those are even numbers, so they can be divided by 2. So we'll take a GCF of 2. So we have 2, and then it becomes y squared minus 16 over 2 is 8y minus 18 over 2 is 9. So we took a GCF out. Now let's factor what's inside. A is 1, so I can go ahead and make a t-chart. We're factoring negative 9 to get a sum of negative 8. So factors of 9 are 1 and 9, and 3 and 3. Since this is a negative 9, one of these factors has to be negative. Since I'm looking for a sum that is negative, the larger factor is negative. And on the 3's, you can just choose one. So negative 3 plus 3, that is 0. So it's going to be 1 and negative 9. So my final answer is going to be 2 times y plus 1 times y minus 9. And so for this, we took a GCF, then we did a t-chart. Looking at number 9, I have 3s squared plus 23s minus 8. 3, 23, and negative 8 do not have a greatest common factor. So I'm just going to jump into my trinomial methods. So my a value is not equal to 1, so I'm going to multiply it over. So MFDRR. So this is going to become s squared plus 23s minus 8 times 3 is 24. Now we're going to factor it. So we're factoring a negative 24 for a sum of positive 23. So I'm going to start with 1 and 24. If I want a positive 23, then I need to make my smaller factor negative. And so negative 1 plus 24 does get you a positive 23. So this is going to be s minus 1 and s plus 24. Now we need to divide, so we're dividing by the original a, which is 3. So divide each of these by 3. And then we need to reduce. 1 over 3, it does not reduce, so it's just going to stay s minus 1 over 3. But 24 over 3, that reduces to 8, so this is going to become s plus 8. And finally, we need to rewrite. We don't want that fraction, so bottoms up, move that 3 in front, we get 3s minus 1, and s plus 8 can stay as is, so s plus 8. So for this one, all we used was MFDRR. Lastly, on number 10, again, we need to look for a GCF, so we are going to look, I have an x in common on both of these, so I'm going to factor out an x. And so x squared, you divide it by an x, you're left with x. Negative 7x divided by x is just minus 7. Now looking at what's left inside, x minus 7 is not a difference of 2 squares, so all we can take is a GCF. So go through these problems a couple times if you need to. If you have any questions, ask your teacher. Otherwise, good luck on the test.